Okay, so this is a test run for my Forward.js talk, and this is about immutability. I'm Swix, I work at Netlify as a developer experience engineer, and we care a lot about what's changing and the trends that are going on, and we also like immutability, as I'm going to talk about. But the first question I think a lot of people who are new to this ask is, why immutability in JS? Typically, you have immutability because you have multi-threaded environments and you want thread safety. But JS is single-threaded, so why even bother? And to answer that, I throw these two images, and hopefully some of you are young enough that you remember, or old enough that you remember hard disk drives on the left, and then they've been taken over by solid-state drives on the right. And why are solid-state drives fundamentally better? There is one industry metric that we call mean time between failures, MTBF. And for hard disk drives, it's 500,000 hours typically, and solid-state drives go up to 2.5 million MTBF. And that's because they fundamentally have fewer moving parts, which means they're less breakable. The software analog of this means that your software is less breakable because there are things that there are just solid units, and that also means it's more debuggable. But there are typical software solutions software engineering solutions to deal with this. For example, adding types to make it more debuggable, adding tests to make sure that things don't break, or just have manual code review because that scales. But really, what immutability helps us answer or helps us rule out is functions like this, where we have an object, we pass it into a function, and then we have to try to work with that object going forward. But we have no guarantees on what that object is, because the function is allowed to mutate any collections in JavaScript, meaning objects and arrays, and it's allowed to do whatever. So in short, the answering the question, can I delete this? Can I refactor this? Can I move this around? Can I throw in a function inside it? Can I throw in a function around it? All that stuff makes you have to load more of your code in your working memory, and that goes away if things are immutable. So, and it helps you avoid situations like this when you try to delete a block of code, and then everything falls apart. And in general, people tend to talk about this as making your code easier to reason about. I don't like that because I can reason my way into very unreasonable things. But mainly, I want software to be more explainable and not to have us put in the same category as UFOs. The last bit about immutability is performance. And this is the original pitch about performance. So let's say you have a nested object tree, and you want to shift an object from one branch to another branch. And that's a fairly expensive operation. And for the young kids in the room, I made a meme to describe this. So full reconciliation, which is checking every single node, and then checking where they moved, and then checking what has changed and where they moved. That's an O(n) to the power 3 operation. With React, we take a shortcut where we just assume that any child of something that's moved needs to be completely re-rendered. So that's an O(n) operation. But if you layer Immutable.js on top of React, you're actually faster than React itself, because you can assume that siblings of stuff that siblings that haven't been changed don't need to be completely re-rendered, and that's an O(log(n) operation. For further details, definitely check out this talk, the original talk by Lee Byron on Immutable.js. Immutable has 26,000 stars, and it's got a couple million weekly downloads. Definitely a very successful project on selling immutability for JavaScript engineering. So let's go into a little bit about the Immutable.js API. And going back to that example earlier, we now wrap objects in something called immutable.map. And now the function that we have is now immutable. So no matter what the in-between function does, we have the guarantee that we can still do whatever we like to the function afterwards, because it has not changed. That's a guarantee we get from immutable. So we have a whole bunch of getters. So for example, if we have nested objects, we write data.getIn. So all right, we have get and get in. If we want to check for existence of a key, we have has and has in. And then what about first and last? I don't know what that means because math doesn't have order, but just roll with it. We have find and find key. Oh yeah, there's a difference between keys and values and entries, and then there's find last key, find entry, and then just a whole bunch of utilities to help you express what exactly you need. And let's talk about setters, because obviously getting a thing is not that interesting. You need to set things, and that's where immutability comes along, where it forces you. You have a nested object, you set in that series of keys, and then it forces you to assign to a new variable. You can't assign to the old variable because it's immutable. And so then you have set and set in, you have update and update in. Obviously, you have delete, you have clear and delete because that's different, and then you have 4 different kinds of merge. So that's very helpful. And in fact, I was able to make a wallpaper with all the APIs in Immutable.js. And surprisingly, that's only one of the data structures offered by Immutable.js. There's map, and then there's ordered map, set, ordered set, list, sequence. I don't know. So the pertinent question it really is to ask why. Why did Facebook? I mean, Facebook is smart people. Why did they feel the need to have this? And the answer comes in the sense, and it really feels like, I wanted immutability, and then I got all this stuff coming in, and I didn't really ask for this, but it just kind of happened. And the answer for this is persistent immutable data structures. That's what Immutable.js offers at its core. What that means is instead of storing your object as an object, it hashes everything into a binary trie, which is very efficient at lookup and deletion and replacement and structural sharing, which is what makes it fast. So the references to things that have not changed are just preserved, so that's free. And then the references to things that have changed are incorporated. And that's something that Jordan Walk, the creator of React, strongly recommends, which is make your developer experience good by regenerating the whole thing every time, so that it is just fundamentally easier to debug. But then add caching and structural sharing to make the user experience better. And that's about it. I call it the DX UX mullet, which means, it's basically like try to have an immediate mode in front, something that's flat and easy and nice to understand, and all the messy stuff that's sort of retained mode, put it in the back. You can see a lot of versions of this across all sorts of software engineering, including Git, including in React, as well as Netlify. We help you deploy your static sites immutably, as well as your serverless backends in an atomic deploy. So you can just roll back and forward all of them, and they technically won't break if you don't publish any breaking versions. So they move in lockstep. But all APIs need an escape hatch, and Immutable.js has a big one because it's based on persistent immutable data structures. You have to translate back and forth from the trie to JS. This is very slow. It's basically JSON.stringify for objects and arrays. And it's an anti-pattern to do that in your code base. Unfortunately, a lot of people end up doing this. They also end up trying to console log stuff and getting all these internals that are exposed. So much so that people write browser extensions to format that, and then helper libraries, because Redux needs to interoperate with that. So it's Redux immutable, and then React Router Redux immutable, and all this other helper libraries that just spreads throughout your code base. In Netlify, we use Immutable.js, and if we import Immutable.js 1x, I did a grep, and I found that we're using the APIs in 2x the number of files that we imported, and we're using it 10 times, and we make API calls 10 times for every single import that we use. So definitely a sort of spready code and API. So the problems are in 2 words, in 2 points: learning curve and interoperability. To solve that, I need to take a little detour and talk a little bit about ES6 Proxies. Proxy, if you're not familiar with it, it's fine, because most people should not have to use it. But a proxy really is a wrapper around an object or an array, and you can define the wrapper to trap or intercept anything that's being done to that object. So, for example, here I have an object food bar and a handler which overrides the get property. So whenever I try to get something from this object, instead of the proper value bar, it returns 42. So that's an intercept of the get operation. Of course, you can also reflect whatever was supposed to be gotten, and then you can also interject whatever logic you want. So here I'm reflecting the internal the wrapped object, but inside it I can also do arbitrary logic, for example console logging or storing it to another variable. And that's the core intuition behind what we're going to do. So of course we have get, and now we have set, and the reflex API basically helps you duplicate the behavior of what normal JavaScript would do anyway, but it lets you insert yourself in the process, right? So here I'm setting, and I'm also putting a console log, and the console log is calling out whenever I'm setting as well. So if I take getting and setting, I take the handler and wrap it in a produce function, and I make a copy of whatever is passed in, and I only make modifications to that copy, I get something pretty close to immutability because I don't modify the original variable, and I can freeze the new variable that I return. So let's use this produce function in context. So here I have an object, and I wrap it in produce, and now I get back and now I write a callback with a draft variable, and I can mutate it however I like because I wrapped draft in a proxy. And so now anything I do to this draft will not be reflected into the original object, but it will be produced in the new object over here. And that kind of looks like Immutable.map and set in and all that, but we just have this one API. So that's so obviously I've walked through a simple example of produce, but if you productionize it and make it extensible, usable in arrays, you can have something like this where you have an array of objects. You throw it into your produce function, and now you have you take that draft now and you can index into it with an object. You can do .foo, and you can set it. You can push new stuff into the array. You can destructure from the objects. All this natural JavaScript stuff you don't need APIs for if you just use JavaScript and proxies. The other cool things that Immer does, it has an ES5 fallback because proxies don't transfile back. It also offers structural sharing. It's a quarter of the size of Immer, and it could be smaller if they drop some support. There's a currying API, there's patches API, and the performance in terms of benchmarks is equivalent to Immutable.js. So it's all very successful. But the core question that we're here to answer is, why is immutability changing? And really, it's the realization that we've come to over time that immutability is not the same thing as persistent immutable data structures. We wanted immutability, we're sold on immutability, but we got Immutable.js. And it's really the realization that it's a bundle, Immutable.js is a bundle of immutability, persistent immutable data structures, and some poor man's form of Lodash. So what Immer took from that is that we can only take immutability, and instead of a custom data structure, we can just use objects and arrays. And instead of Lodash, we can just use everything that we use in JavaScript, including real Lodash. So Immutable.js has a lot of moving parts, and Immer doesn't. I don't know about that. Okay, Immutable.js has, by my count, about 100 something APIs. Immer has one, and you've already memorized it. So here's the chart of the relative sort of downloads and usage over time. Immutable's grown, and then Immer had a monster October, November, and now it's going to new heights. But interestingly, Immutable.js actually has stopped growing, and I think a large part of it is the existence of an in-between option that better suits people's use cases. So what can we learn from our general journey through this recent history? First is to take something that's successful, that people want, and make it less annoying to write. Dan Abramoff did this for the Flux architecture with Redux, and definitely Immer seems to fit that vein. The other learning is that small APIs are better than writing your own domain-specific language. And that's a shout out to Rich Hickey. Anytime you mention simplicity, you have to pray to Rich Hickey. Also the power of scope. Scope is very powerful for limiting the scope of your API. I mean, I feel silly using the word again, but within your scope, you can define whatever rules you want. You can have local mutability. You can React hooks. You can do just literally anything, and it's guaranteed to not spread to the rest of your code base, which is really good for incremental adoption and interoperability. So that's very nice. And the last bit is always bet on JavaScript. Anytime you're writing an API and thinking about the different ways to access and manipulate data, think about how regular JavaScript can do the job. So the message is you may not need Immutable.js. Thank you.